What we have here is the diagram shows three parallel lines L, M and N to cut equal intercepts at the line U. The phi makes an angle of 60 degrees, as you can see with the vertical as shown. If AC is 16, find DE. Okay, so what we can see is that AC is here to here, okay, and we can also see that DE is half that distance. Must mean DE is 8. Everybody alright with that? Half the 16. Okay. Now, if GH is 22, find the angle HEF.
Wait, is DE? How would you tell DE is straight down and not like diagonal across?
Oh, sorry, I haven't found DE yet. Sorry, I found DB. Oh, sorry, I found this distance here. So I haven't found DE yet. Sorry, I jumped the gun. So it's actually 8 here, 60 degrees here, and find DE, which I'll just call X, okay? So that's the hypotenuse, that's the adjacent. So I'll use cos 60 equals adjacent divided by hypotenuse. X equals 8 divided by cos 60. And what's 8 divided by cos 60? Is it? I don't. Yeah, you're right. It is 16, sorry. X equals 16. Okay. What page is this on, by the way, lads? Sorry? 2. Thanks. Okay, next one. If GH equals 22, so from here to here is 22. Everybody got that? That's 22. Calculate the angle HEF. Well, if that's 22, that one there is 11. We already determined that this here is 16, which makes this one 16. I now have a triangle with 11 and 16, and I have to find this angle here. Now, is there any way I can bring this 60 degrees into play somehow?
The angle MEF is 30 degrees.
You said the angle, was it?
MEF is 30 degrees because 60.
MEF. Going for 60.
Must be 30 degrees.
Okay, just give me a second with that. Just still processing.
Oh no, yeah, the one below must be 30, so then we add the
Yeah. I got this is 30.
HFE.
And I got this one here. Sorry, that one's 30. Anybody tell me why that one's 30? 60, 90, 30. See the mini triangle I drew here in black? See this here? It's a mini triangle, okay? That makes that one 30 degrees. Now I'm going to use opposite angles. How do we use opposite angles? Opposite angles, anybody? Opposite is, remember the letter X. So this here is going to be 30. This has to be a, what is it, a straight angle, isn't it? Oh, it's not a straight angle just yet. Just give me 1 second.
So the angle HFE is 30 long.
The angle HF?
HFE is 30. Right.
Just give me a second. Alternates. Okay. So we know that that's 30. What other one can we get then? I'm just going to...
You know the two sides and angles.
Oh yeah. So we have two sides and one angle. We got the 30, so now we can figure out what this angle here is, okay? We call it angle Y. Let's start off by figuring out what angle Z is, okay? So we're going to use what rule, the sine or the cosine rule? Sine rule. Sine 30 is looking at the 11, and that equals sine Z over 16. Bring the 16 up and sine inverse it. So Z equals sine inverse. When you bring the 16 up, it's up here. Sine inverse, will somebody put that in the calculator? 16 sine 30 over 11? Let me know what it is when you get it. So what do we get? $46.66. Okay. This is now 46.66. We weren't asked to get that, we were asked to get the other one. So how do we get the other one? Which is angle Y. Add it up and take it away from 180, and what do we get? 103.34. 103.34. Everybody alright with that? That's your answer in the back. Now, what we gotta do next is, it says, hence find the area of this triangle, HEF. Remember, HEF is this triangle down here. We have all the angles, and we have a side of 16 and a side of 11. So, yeah, you said it, go again. Have AB sine C, which is a half 11 times 16, has to be the angle in between. So sine 103.34. Put that into the calculator, let me know what you get. .6255, so 85.63 units squared, right, or centimeters squared. It says, using this area or otherwise, find HF. HF is this distance here. I have several options. I have sine rules, I have cosine rules, and I have so much information, or I have area. I'm going to use area just because I think it's going to be really easy. I'll show you why. We said that's 85.63 is the full thing, right? So look at this. A half, call it x, yeah? A half x times 16 sine what? 30. Remember, the half AB, any angle, will get you the area, okay? So it's going to be, what's going to be? 8x. So x times 8 sine theta, okay, or 8 sine 30.
No, sir, doesn't the angle have to be opposite side?
Nah, not for area. For area, it's side angle side. For area of a triangle, a half AB sine C.
AB sine C, where C is the opposite angle from the side.
No, that's only sine rule. Only sine rule does have to be opposite. No. In the area of a triangle formula, it's the angle that's sandwiched in between the two sides.
Oh, okay.
Okay. So what you're going to get here, guys, is x equals what's 85.63 divided by 8 sine 30. What you get?
21.4.
Now, just for completion's sake, we're going to run this using the sine rule as well, just to prove that's the same thing. Okay, remember 21.4. Now, once again, this is what you're talking about. X being here, yeah? X over sine of the angle opposite it, which is 3.34. Pick any other side and the angle opposite. We can use 11 over sine 30, or we could have used 16 over sine 46.66. Cross multiply up and tell me what 11 sine 103.34 divided by sine 30 is. I'm hoping it's 21.4. So we put it in. 21.4?
Yeah, well,
Yeah. So if you do the cosine rule, get the same answer. Any of them will give you the same answer, okay? Now, using this formula here, now let me explain what this formula here does, okay? Have any of you used this formula yet? Don't know if I did it back in geometry or not, I can't remember this, but it's a really easy formula to pick up. It looks massive, it looks really difficult, but it's basically, what was it, 21.4? 21.4, okay? This is a formula for getting the area of a triangle when you have 3 sides and no angles. So let's say, for instance, there's no angles, and we were just given that at the start. You could do the cosine rule, find an angle, and then do a half AB sine C. Do you understand that? Cosine rule would find you an angle, then you could do a half AB sine C. This way gets you a direct link to the answer straight away. What you do is you name all the sides A, B and C. Okay? Then you're going to find out the S value. The S value is simply add them all together. So maybe on the calculator with this. Add them all together and divide by 2. 24.2. Once you know what this 24.2 is, you put it into the area formula. The area formula is your S value. What's our S value, guys? It's going to be 24.2 multiplied by 24.2 minus 11. 24.2 minus 16. And 24.2 minus 21.4. Put that all in to the calculator. It should turn out to be, was it 84 or 85, wasn't it?
86.6.
86.6, is it? 85.64. 64, yeah. Roughly what the area was last time, yeah? So there you go. Two different ways of getting the area of a triangle. Half AB sine C and that formula there. Okay? You probably need to practice that one again. Okay? Now these ones. So let me show you what you probably already know. When all 3 points are on the circle, yeah, and one of them is the center of the circle, the angle that's here is twice the angle that's here. That's a rule set in stone. The answer is 70. Same question, except this time the angle is, which makes this 90. Now, this is also true. If you have a triangle where all 3 vertices are on the circle and the diameter goes through the center of the circle, it has to be 90 degrees. Okay, has to be. Okay, next one. If you have 2 angles and they stand on the same arc, so this is the arc here, do you understand? So we have 2 lines, okay, we have a red line, I'll do it now, just need some colours here. Okay, so see the way they have the same start and end point. See the way that one starts at red, goes up here and goes back down, and see the way the other one, which I'll do in green, starts up here and then comes back and end. See the way they have the same start and end point. When that happens in a circle and all the points are on the circle, that means they're the same angle every time. Everybody got that? So that is 40. Okay, next one. This is what's called a cyclic quadrilateral. Anybody want to tell me what that means? Quite a mouthful. Sorry? Four-sided shape, okay. And what happens is all 4 angles have to add up to what? Have to add up to 360, okay? Now, and there's one other rule with them. Opposite angles have to equal
180.
only for cyclic quadrilaterals. Do you understand?
Yeah.
A normal quadrilateral, an example of a basic ordinary quadrilateral would be a parallelogram. And as you can see in a parallelogram, it's quite obvious to see that the opposite angles, they don't add up to 180. They add up higher than 180. So please remember that. Okay? So what we're looking at is that Q is going to be 95. Why is it going to be 95? Because that has to add to 85 to get you 180. And then the other one's going to be 102. Now you have a straight angle here, which will put that to be, oh sorry, 85. Are we happy with 85? Okay. Now, this one here, cyclic quadrilateral. Everybody be happy with that? Yeah?
Yeah.
Go straight for P. What does P have to be? And then Q is 140. I used the information of 110 combined with 70 because I knew they had to be 180. Okay? Okay. Now, can anybody tell me what Y is going to be?
32.
How do you know it's going to be 32?
Same points.
Same points on the arc. See, the 32 starts and ends at the 2 black dots, and the other 32 starts and ends black dots. What is the X going to be then? See the X here?
64.
It's going to be 64. How do you know 64? double the 32 to get 64. And what is the Z going to be? What type of triangle is it? Isosceles. Why is it isosceles?
The length of the radius.
Length of the radius. Take
You have to presume that
the radius. So take away 180, or sorry, that from 180. 116 divided by 2. 58. They're easy once you've practiced them a couple of times, but they're not. They can be sometimes very hard for something that's so short.
You just have to be able to see it.
What?
You don't have to prove it on
You did at junior cert. There's gonna be times where you're gonna need part of your proofs to prove two triangles are the same. We're gonna get onto that further down. Okay. What can you tell me about this one, guys? This X here. X is? Anybody? X is going to be 59. Okay, that's easy enough. Now, I'm going to do, this is what I was talking about. I'm going to do construction. And I'm going to draw a green line straight through that angle. It doesn't bisect it though. Can anybody tell me what this angle is in here? You should be able to. Why is it 34? Isosceles triangle, both radiuses are the same. 34 from 59, get you? 25. This is also an isosceles triangle, so there's two 25s, isn't there? Is Y meant to be 25 or is it the big angle? You can't see it
It
now.
looks like 24.
Okay. Yeah, it's a 25. This one here. 28 on the outside, which will mean what's going to be here?
62.
62. What type of triangle are we looking at? Another 62. Take away from 180.
56.
56. 56 from 180. 124. This angle B is the same. It's the same angle twice. Once again, isosceles triangle. What do we? 28 and 28. Okay. The next one. This one up here. Any ideas what to do here? What did I do here? 25. 130. 50.
X. You know, just work out X straight away because you know that one does not.
This is 90, so I'll need the 50 because 90 take away 25. 65. So now you have X in a triangle with 65 and 50. So take them away, and what do we get? X is also 65. Okay, so X is 65, lads, okay? So what does Y turn out to be? Y is going to turn out to be 40, but why is it going to turn out to be 40? Let me see. Sorry?
150. Oh, sorry.
Okay, just going to make the diagram a bit bigger. I'm actually struggling with the size of the diagram is really
There's another triangle there.
off-putting.
You work at the top angle.
No idea what that sign is. What is that? Okay guys, there's something I've never seen before on my laptop. It's really confusing me. It's some sort of rake. We can't speak too much because I'm still recording, but it's basically not listening to me at the moment. It's a sign, but it isn't working. Like, I don't know what this is.
Make a compilation of all.
Okay, so lads, what we have here is we already agreed that that's 25. We agreed that that is was a 130. That's 50. That was 65, and that there was
65.
65 as well. That makes this angle in here 115. Sorry, you're right. 115. And then we need to find out 115. Is there any way of finding out this? We need to find out 40. I'm trying to figure this out.
If it's a tangent, it makes.
Oh, 90. So this here has to be another 25. And then 25 plus the 115 gives you 140 plus the other 40. Key thing is the tangent here. That angle there has to be 90. That's what Fagan said, okay?
How do you know tangent is to that?
Tangent always has to hit at 90 degrees.
But how do you know it's 90 degrees to that particular line?
This point here to this point here, Connor.
Yeah.
Every time.
But that, like, how do you know that that's perpendicular? Like that
It has to be.
All tangents.
All tangents are perpendicular to the centre of the circle.
But I mean,
Does this line here, Connor? The point of tangency back to the centre of the circle has to be 90 degrees.
Right, it doesn't really look perfect.
That's because I distorted the image when I was. I know, that's, remember I had to resize it. So it's basically what's happening to you there is this. Basically, I had to resize it so it looks more like it now. Okay. The wonders of technology today. Now. Failed compilation, most definitely. Now, this one here, number 12. Anybody have any ideas for number 12?
Alright, let's go.
Right, that's 38.
You can see it as the same line.
52. Shh. 90.
Yeah.
90.
Yeah.
This one here.
It's got to be 180 minus 45.
45s. Okay. And this one here has to be 52. What we asked for anyway? QS.
That's not 52.
Q or S.
No, it's not 52.
Oh, it's not 52. Sorry.
But it has 38.
Wait. Ah, sorry. I get it, guys. Shh. Sorry. That's 52. That's 90. That has to be 45. That has to be 45 on the basis of being isosceles.
Yeah.
That leaves this one angle left over. Add them all up, take it away from 360, it's going to be 38, or take away from 180 in its own triangle to the right. Okay?
It was 78.
Everybody happy enough with that? Now, I'll leave 14, which is for later on. I've done a lot of these already, so we're just going to leave it with you. 16. Okay. What we have here is O is the centre of the circle. OM is parallel to is perpendicular to AB. Find AB. Lads, you've done this in the circle already, haven't you? Now in the circle chapter. Radius is 13. Do Pythagoras' theorem, and you get 12. 12 multiplied by 2, 24. Yeah, some of them, they actually get hard, easy, hard again, then easy again. It's really weird. Shh. Okay. In the diagram, O is the centre of the circle of radius 17. Okay, same, more or less the same thing, isn't it? So we go from here down to here. What's the radius? 17, right? Point on PQ such that OX is 15. Find AB. Once again, Pythagoras' theorem. And what is Pythagoras? Some of you get 17 squared minus 15 squared, then multiply by 17 squared minus 15 squared and square root the answer. Is it 8? Okay, so 64. When you do Pythagoras' theorem, you find out that that's 8. That's 8. Therefore, the whole thing is 16. Next thing you have to find out is A to Q. See A to Q? Almost right. It is Pythagoras, you're right.
You just double the angle.
No, not necessarily.
Which is 90.
Okay, so guys, what are you going to do?
45 degrees.
15 from here to here, 17 from here to here. Makes 32 on the bottom. 8 on the top. Pythagoras' theorem that to find out what this is here. Everybody happy enough with that? Okay.
So I've got an easier way of doing that, I think.
Okay.
There's no easier way than that.